For the second part of this lab number 2, the same code that was put in part 1 was modified so that we can have all the colors that we mentioned in a table that can be created by the RGB LEDs actually flash without actually hitting the switch. That code was modified and then saved, and then another file was made to save the actual unedited code so that both could be turned in. So same directory, 00MDK boards, NXP, Freedom KL25Z, and then this is a different folder name, chapter 2, and I have it open here. The modifications I made, I did not remove any of the voids, just in case I needed to go back and look at them for reference if I was doing something incorrect. But what I did realize is that we needed to keep the void that would set the outputs, make the GPIOs. So in this case, initialize RGB LEDs is what's gonna make those pins GPIOs and then set them to outputs. We need to keep that because our LEDs are GPIOs, they're running on that, and they are our outputs. So we do keep this void. The control RGB LED gets changed. So initially in the first part of this lab, we ran it with a switch. The switch was looking for this void. I apologize. The control RGB void was looking for this, where it was looking to see if the switch was active, and if it was active, which direction, and it would feed into control RGB LEDs, and then that would determine, okay, is the red on? If it's up, is the red on? If it's left, is the blue on? If it's right, is the green on? And then turn it on if it is. In this case, we want them to run without the switch, so I commented that one out. Also here, the test switches here, and the initial 5-way switch because we don't need the 5-way switch. We had an edited control RGB LEDs code that was given to us that had the first couple of colors. Basically, the way it is to turn on and turn off outputs is that here the port for whatever LED it's connected to. So for example, the red LED is port B. We communicate to the output register, OR. To turn it on, we clear it. I apologize, I'm a little off on there. And to turn it on, we set it. So for our lab questions, we figured out what would need to be on, red, green, or blue, and which combinations of them to make each color. Obviously, red would just be red, green is just green, blue is just blue, yellow is red and green, teal is green and blue, magenta is red and blue, and white is all 3 colors on. So all I did was take each color combination I needed, and when I wanted them on, I just subsequently had them turn on. So to turn on yellow, for example, port B, output register, I cleared it for the LED that I wanted on. Same thing, port B, cleared it for the LED that I wanted on. Obviously, these 2 LEDs go to B, and blue goes to D. So when I compile this, 0 error, 0 warnings, I can enter debug mode, run my code, and here, it's a little blurry, I apologize, I have my colors flashing. So okay, it's gonna flash there. So it's red, green, blue, yellow, magenta, and then teal. Sorry, it's a little blurry. But as you can see, I'm not touching the switch. This is just running. And in between each one, we have a delay. Oh, well, that was another thing we added. A delay void, which basically is going to loop for the amount of time we put. It loops enough to make it 2 seconds. That delay void is right here. So it'll just go for the time that we set, decrement. Once it expires, then it goes to the next set of code. And we have all our colors flashing.